What if I told you that right now, somewhere in the unimaginable depths of our universe, two cosmic giants are locked in an endless clash so epic it makes every superhero blockbuster seem like a playground scuffle? Welcome back to Core IQ, the channel where we plunge headfirst into the mind-bending mysteries that make our universe the most awe-inspiring place you could ever imagine. Today we're tuning into the ultimate galactic showdown between two of the most powerful forces science has ever uncovered, black holes and supernovae. And picture this. On one side we have black holes, the universe's ultimate destroyers, so powerful that not even light can escape their gravitational grip. On the other side, supernovae, stellar explosions so brilliant they can outshine entire galaxies containing billions of stars. These aren't just random cosmic events, they're the architects of everything we see around us, including the very atoms that make up your body. But here's what's going to blow your mind. These two phenomena are more connected than you might think. And by the end of this video, you'll understand why one literally gives birth to the other in the most spectacular way possible. We're about to embark on a journey that will take us from the birth of stars to the death of galaxies, and trust me, you won't want to miss a single second of what we're about to uncover. Let's start with supernovae, because every great story needs an explosive beginning. Imagine a star so massive that it makes our sun look like a grain of sand on a beach. We're talking about stars that are 8, 10, sometimes even 50 times more massive than our own solar furnace. These stellar giants live fast and die young, burning through their nuclear fuel at an absolutely staggering rate. For millions of years, these massive stars engage in a delicate balancing act. The outward pressure from nuclear fusion in their cores fights against the inward pull of their own gravity. It's like a cosmic arm wrestling match that seems to go on forever. But here's the thing about massive stars. They're doomed from the moment they're born. As these stellar behemoths age, they begin fusing heavier and heavier elements in their cores. First hydrogen into helium, then helium into carbon, carbon into oxygen, and so on, creating layers upon layers like a cosmic onion. But when they start trying to fuse iron, that's when everything goes catastrophically wrong. Iron fusion doesn't release energy, it actually absorbs it. Imagine trying to feed a fire with water instead of wood. The moment a massive star's core becomes dominated by iron, the nuclear furnace that has kept it alive for millions of years suddenly shuts down. Without that outward pressure, gravity wins the ultimate victory and the core collapses in less than a second. Now, when I say collapse, I don't mean it gently falls inward. We're talking about matter compressed to densities so extreme that a teaspoon of this material would weigh as much as a mountain. The core shrinks from the size of Earth to just 12 miles across in the blink of an eye. The shockwave from this collapse is so violent that it rebounds outward, ripping through the star's outer layers at speeds of 30,000 kilometers per second. This is the moment of the supernova explosion, and the numbers are almost impossible to comprehend. In just 10 seconds, a single supernova releases more energy than our sun will produce in its entire 10 billion year lifetime. If you could somehow capture all the energy from a supernova and power the entire United States, it would last for trillions upon trillions of years. But the real mind-blowing part isn't just the energy release. During those few seconds of explosion, the temperatures and pressures become so extreme that the star begins forging elements heavier than iron. Gold, silver, platinum, uranium, all the heavy elements that make our modern world possible, are created in the final death throes of these massive stars. Every piece of gold jewelry, every silver coin, every electronic device containing rare earth elements, they all have their origins in these stellar explosions. The explosion doesn't just create heavy elements, it scatters them across space in expanding shockwaves that can stretch for hundreds of light years. These shockwaves compress nearby gas and dust, triggering the formation of new stars and planets. In a very real sense, supernovae are the universe's recycling system, taking the ashes of dead stars and using them to build the next generation of cosmic structures. Now let's talk about what happens in the core during this catastrophic collapse, because this is where our story takes a dark turn, literally. When that stellar core collapses, if the original star was massive enough, something even more extreme happens. The matter becomes so densely packed that protons and electrons are forced together to form neutrons. But if the star was truly gigantic, even neutron degeneracy pressure can't stop the collapse. This is where black holes enter our cosmic drama. born from the death of the most massive stars in the universe. But before we dive into these cosmic vacuum cleaners, let me tell you something that will change how you think about space forever. Black holes aren't actually holes at all, and they don't suck things in like cosmic vacuums. That's one of the biggest misconceptions in all of astronomy. A black hole is actually an object, an incredibly dense object with so much mass packed into such a small space that it warps space-time itself beyond recognition. Imagine space-time as a stretched rubber sheet, and now imagine dropping a bowling ball so heavy that it creates a pit so deep that nothing, not even light, can climb back out. That's essentially what a black hole does to the fabric of reality itself. The boundary around a black hole where escape becomes impossible is called the event horizon. And it's not a physical surface like the ground beneath your feet. It's more like a point of no return, a cosmic line in the sand that once crossed leads to only one destination. The singularity at the black hole's center, where our understanding of physics completely breaks down. But here's where black holes become truly fascinating. They're not just cosmic destroyers. They're also creators and sculptors of the universe on the grandest possible scale. Every major galaxy, including our own Milky Way, has a supermassive black hole at its center. These aren't the stellar mass black holes born from supernovae. These are monsters containing millions or even billions of times the mass of our sun. These supermassive black holes act like cosmic conductors, orchestrating the growth and evolution of their host galaxies. As matter spirals into a black hole, it forms what's called an accretion disk, heating up to temperatures of millions of degrees and glowing brighter than entire star clusters. The energy released by this process can actually regulate star formation throughout the entire galaxy, determining whether new stars will be born or whether star formation will be shut down completely. Now here's where our cosmic showdown gets really interesting. Black holes and supernovae aren't just related. They're part of the same cosmic cycle, different acts in the same grand play. Many black holes are born from supernovae, but the relationship goes much deeper than that. Let's consider the scale of destruction each phenomenon can unleash. A single supernova can sterilize planets dozens of light years away with deadly radiation, potentially causing mass extinctions across multiple star systems. The explosion is so bright that it can be seen from billions of light years away, temporarily outshining entire galaxies. For a few weeks, a supernova can be brighter than 100 billion stars combined, but black holes operate on a completely different timescale. While supernovae are flashy and dramatic, burning bright and fast, black holes are patient predators that can influence their surroundings for billions of years. They can slowly tear apart entire star systems, feeding on them piece by piece over cosmic ages. Some black holes launch jets of material at nearly the speed of light, creating structures that stretch across hundreds of thousands of light years. When it comes to pure destructive potential, though, we need to consider what happens when these phenomena interact. Imagine a scenario where a massive star is orbiting close to a black hole. As the star begins to swell in its final stages before going supernova, the black hole can actually strip away the star's outer layers before the explosion occurs. This creates what astronomers call a stripped envelope supernova, an explosion that's different from the classic supernova we described earlier. But the most spectacular interactions occur when two black holes spiral into each other and merge. These collisions release more energy and gravitational waves than all the visible light from every star in the observable universe combined. The ripples in spacetime from these mergers can be detected by instruments here on Earth, even when the collision occurred billions of years ago and billions of light years away. Here's something that might surprise you. Supernovae might actually be responsible for creating the conditions that allow life to exist throughout the universe. The heavy elements forged in these stellar explosions are essential for building rocky planets like Earth. Without supernovae, the universe would contain only hydrogen and helium, making complex chemistry and life as we know it impossible. But supernovae also pose one of the greatest threats to life in the universe. If a supernova occurred within about 50 light years of Earth, the gamma radiation could strip away our ozone layer, exposing all surface life to deadly ultraviolet radiation from the sun. Some scientists even theorize that past mass extinctions on Earth might have been triggered by nearby supernovae. Black holes present a different kind of threat. While they don't directly threaten life over interstellar distances like supernovae do, They can completely sterilize entire regions of galaxies. When supermassive black holes become active, feeding on surrounding matter, they can emit so much energy that they halt star formation across vast regions of their host galaxy. No new stars means no new planetary systems and ultimately no new opportunities for life to emerge. The timescales involved in these cosmic phenomena are almost incomprehensible. A supernova explosion lasts for months or years, but its effects ripple through space for hundreds of thousands of years. The expanding shockwave continues to heat and compress interstellar gas long after the initial explosion has faded from view. Meanwhile, black holes can remain active for billions of years, slowly growing larger as they consume more matter. But here's perhaps the most mind-bending aspect of our cosmic showdown. Both phenomena are ultimately governed by the same fundamental force: gravity. Gravity is what causes massive stars to collapse and explode as supernovae. Gravity is what prevents anything from escaping a black hole's event horizon. In both cases, we're witnessing gravity's ultimate expression of power over matter and energy. The study of both black holes and supernovae has revolutionized our understanding of the universe. Observations of distant supernovae led to the discovery that the expansion of the universe is accelerating, revealing the existence of dark energy. Meanwhile, the recent direct imaging of black holes and detection of gravitational waves from black hole mergers has confirmed Einstein's most exotic predictions about the nature of space-time. Consider this. Every atom in your body except hydrogen was forged either in the core of a dying star or during a supernova explosion. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was created in stellar furnaces and scattered across space by these cosmic explosions. In a very literal sense, you are made of star stuff, the recycled remains of ancient supernovae, but the story doesn't end there. Those same supernovae that created the elements necessary for life also created many of the black holes that now populate our galaxy. It's a cosmic circle of life and death that has been playing out for over 13 billion years, shaping the universe we see today. Looking toward the future, both phenomena will continue to play crucial roles in the evolution of the cosmos. As the universe ages and star formation slows down, supernovae will become increasingly rare. Eventually, billions of years from now, the last massive stars will explode, and no new ones will form to replace them. But black holes will persist, slowly evaporating through Hawking radiation over time periods so vast that they dwarf the current age of the universe. The ultimate fate of our cosmos might actually be determined by which force wins in the end: the creative power of supernovae that builds new structures, or the destructive influence of black holes that eventually consume everything around them. Current models suggest that black holes will be among the last objects to exist in our universe, slowly evaporating into nothing as space itself expands and cools toward absolute zero. So who wins our galactic showdown? In terms of raw power and immediate impact, supernovae are unmatched. They can outshine billions of stars and create the building blocks of planets and life itself. But in terms of long-term influence and staying power, black holes are the ultimate champions. They can shape the structure of galaxies for billions of years and will outlast virtually every other object in the universe. But perhaps the real answer is that there are no winners or losers in this cosmic battle. Both phenomena are essential parts of the universe's grand design, each playing their role in the ongoing story of cosmic evolution. Supernovae provide the raw materials and energy needed to build new worlds, while black holes provide the gravitational scaffolding that holds galaxies together and regulates their growth. The next time you look up at the night sky, remember that you're witnessing the aftermath of countless cosmic battles between these titanic forces. Every star you see will eventually face its own fate, either exploding as a supernova or being consumed by a black hole. And somewhere out there right now, new chapters in this cosmic drama are being written as massive stars approach their final moments, and black holes continue their patient hunt for new material to consume. The universe is not a peaceful place. It's a cosmic battlefield where the most extreme phenomena imaginable play out on scales that dwarf human comprehension. But it's also a creative force, constantly recycling and rebuilding, ensuring that from destruction comes new creation, from death comes new life. That's the beauty of our cosmic showdown between black holes and supernovae. They remind us that we're part of something infinitely larger and more spectacular than ourselves, participants in a story that began with the Big Bang and will continue long after our sun is burned out and Earth is nothing but a memory. In this grand cosmic tale, we're not just observers, we're products of the very phenomena we've been exploring. Living embodiments of the universe's incredible power to create complexity and beauty from chaos and destruction. So the next time someone asks you what the most powerful forces in the universe are, you'll know the answer. It's not just black holes or supernovae alone, but the incredible dance between creation and destruction that these phenomena represent. A cosmic ballet that has been choreographing the evolution of everything we know and love for over 13 billion years.